Hello and welcome to a presentation on which materials would be the most efficient for use in the manufacturing of a bicycle frame. My name is Tristan Maree, and today I'm joined by Scott Mclauglan to discuss and compare the two materials of aluminium and steel. Through examining properties, structure, advantages and disadvantages, and the availability of the material, we can make a clear recommendation by the end to choose which material would best suit a bicycle frame. The first aluminium bicycle frames were starting to get manufactured in the 1970s, which then became more widespread and popular in the 1980s. Aluminium bicycle frames are now the most common material used in the modern bicycle industry. One of the most popular alloys of aluminium used in manufacturing is aluminium 6061. Aluminium 6061 is most commonly used in aircraft wings, yacht construction, automotive parts, and scuba tanks. Properties of aluminium 6061 is it has a low density of 2.7 grams per centimeter cube, it has excellent strength to weight ratio, and it is very high corrosion resistant. This material also has very good weldability. Its ultimate tensile strength is 310 megapascals, and its Young's modulus, or stiffness, is 68.9 gigapascals. Some of these properties are ideal when looking for what properties a bicycle frame requires to function efficiently. The chemical composition of aluminium 6061 is silicon, iron, manganese, magnesium, chromium, zinc, and titanium, which all combined have a contribution of 1.5 to 5%, with the remainder of the alloy being aluminium having 95 to 98.5%. This alloy has a face-centered cubic structure, or FCC, with holding 4 atoms per unit cell, as shown in Figure 1. This FCC structure allows the alloy to be very ductile, giving it a large advantage over the body-centered cubic structure, which is very common in other materials. Aluminium 6061 has many advantages and disadvantages. These consist, as stated before, of an excellent strength to weight ratio, which is perfect for bicycles. It is easy to manufacture, and it has high resilience. And the last important factor that plays a big role is the high corrosion resistance. Some of the disadvantages that aluminium 6061 has is that it is very difficult to repair, and it has a short fatigue life. Finally, aluminium makes up approximately 8.1% of the Earth's crust. However, its price as of 25th of July 2019 is stated to be $1,825 per ton. This poses a problem for the third world and underdeveloping countries, as they might not have the funding or resources to manufacture these aluminium bicycle frames. I will now hand you over to Scott to discuss the material steel.
The development of steel can be traced back 4,000 years to the beginning of the Iron Age. Early examples of steel were found in 1300 BC, when blacksmiths of the day discovered that iron became harder, stronger, and more durable when carbon was introduced after being left in cold furnaces. The yield strength of S275 steel measures the minimum force needed to create a permanent deformation in the steel. This is tested by a minimum yield strength of the steel grade tested at 16 mm thick. Tensile strength tested at a thickness of 16 mm has a maximum of 530 newtons per millimeter squared before permanent deformation takes place when the material is stretched or pulled laterally along its length. Steel has 3 different crystal structures at different temperatures. The room temperature alpha form has a body-centric cubic structure, BCC. This structure has atoms at the edges and an atom in the center of every cube. At 913 degrees Celsius, the alpha steel converts into austenite, and the structure becomes face-centric cubic, FCC. This structure has a coordination number of 12 and contains 4 atoms per unit cell. At 1394 degrees Celsius, the austenite turns into delta phase and transforms its structure back to BCC. Steel is cheap, extremely durable, extremely fatigue resistant, simple to repair, and simple to use. Unlike carbon fiber and aluminium, it is usually easy to repair any damage done to the steel frame. Slightly surprisingly, despite its strength, thanks to its elastic characteristics, steel provides excellent compliance rates. The downside of steel is that it is prone to rust and imposes a weight penalty on other materials. Because of steel's low cost and ease to manufacture, steel has a high availability around the world. Steel's longevity and low manufacturing costs make it the best option out of the two materials discussed for third world countries. Steel's frames sacrifice weight for durability. Aluminium is lighter, but in the event of a crash, aluminium will usually crack rather than bend, making repairs difficult and sometimes impossible.